So we will be working on the analytics with your Jobathon data set, CTR prediction. The data has been emailed to you. And imported both the train and test file. Description is also there. So I would request all of you to read the description also, data description text also once after you import the data set. So CTR train dot shape, CTR test dot shape. So 1888, 22 variables, 762, 21 variables. So subject length is numerical as per the data description sheet. If you see the data description, subject length is number of characters in subject. Body length is number of characters in email. Mean paragraph length is average number of characters in paragraph of an email. Then number of CTA, number of call to actions in an email, mean CTA, average number of characters in CTA, is underscore image is number of images, is underscore quote is number of quotes. Then is underscore emoticons is number of emoticons in the email. We also have click-through rate, which of the email campaign, which is our dependent variable, but we will deal with dependent variable later. Okay, we will take dependent variable as separate. So the dependent variable click-through rate is also a what you call a numerical variable only. Now we have to separate the object calls. So campaign ID, no. Sender, no. Subject length, body length is done. Mean average is done. Day of week. So day of week is categorical. Is weekend is categorical. It's a Boolean. What is Boolean?
True or false?
True or false. Yes. Then times of day, morning, noon, or evening. I think it's a category. It is given as categorical data. So times of day, morning, evening, afternoon. Then what else we have after times of day? Category. Category is categorical. Product is categorical. Then what else? Category, product is personalized. Is personalized, is timer. Is quote is numerical. So is timer is
So
categorical.
we can drop is timer, like it has no values, it's just zeros.
That we will drop later, no?
Okay.
We will drop later. How will you know? We have to follow the process, right? So once we run the value counts of all the variables, then we will identify and then download. We can't decide it now only, right? Because we are going through a process.
Okay,
You
sir.
might have already done it, right?
Yes, I did already.
So, but the rest of us, we have not done it, right? So that's the reason we need to follow the process. Is personalized, is timer, is discount is also a Boolean. See, Booleans are all categoricals. So when it says Boolean, you don't need to worry. It is, you can take it as categorical. Is underscore price, Boolean. then is underscore urgency, Boolean, then target audience, which is the cluster label. Okay, so these are the numeric calls and these are the object calls in our data. So we also need to do the same thing with the test data. Test underscore num
Sir,
underscore calls. Yes, please.
sir, before splitting num calls or object calls, we have to combine data.
You
Train
can
or
combine that also, but this is the second process which we can also follow. Because one of the participants asked me, why can't we do it separately? So till now we are combining and doing it. Today we will do it separately.
yeah,
It's your
okay, sir.
comfort. You can combine and do it, no problem, right? Or
Okay, sir.
you can do it in a separate manner also.
Okay, sir.
Okay, so to understand the process, how to do it separately, I am showing you though. Because till now we are doing just only what you call one way, right? So this time we will also do two types. So all you do is copy the list of columns, paste them here. Similarly, test underscore object underscore calls is equal to CTR test double square brackets. You can copy the categorical calls, Control C, Control V, and run it. Once you're done, please confirm.
So why didn't we take dependent variable in the num calls? Right.
See, dependent variable in num calls, we can take it, but test data does not have dependent variable in
Yeah,
num.
test data doesn't have it.
So
Yeah.
anyway, we have to separate dependent variable, right? Why?
Mhm.
Y has to be treated separately, right?
Yes, sir.
So we will treat it separately only. We will use it when we do it on Y. When we create X, then we also have to create Y, right?
Mhm.
That time
Yes,
we'll use
sir.
Y directly. You want, you can add it also. But no point, na? Because that's a different analysis. We have to do on dependent variable, where we have to do histogram, box plot, density curve, and all to see the distribution, right?
Mhm.
That we
Yes,
can do
sir.
it later as Y. All right, all of you have done this categorization.
So wait a minute.
Yeah, please, I'll wait. No problem. Once you're done, please confirm.
Sir, excuse me, sir.
Yes, please.
Sir, I'm getting an error that list indices must be integers or slices, not lists, sir, when I'm trying to separate object columns from test.
Did you give 2 square brackets?
Yes, sir.
Okay. Check the commas. You might have missed a comma somewhere.
Yes, sir. Checking, sir. Commas are correct, sir. I copy pasted.
Okay, give me your any days. Let me check.
Okay, sir.
Hello. Na kaka. Thank you, Anna. Full holiday ఎక్కడన్నా మాకు I think you put a double is equal to here. You put an is equal to here also, okay? Got it, all of you? Sorry,
Okay.
Ashish?
Okay, sir.
Okay, so
So,
let us.
so I
Yeah,
have an error when
Yeah.
when I check the shape of train object calls.
What error you are getting?
List object has no attribute shape.
Okay. Did you give double square brackets? I think you have given single square brackets. If you give single square brackets, it will be considered as what you call list. If you give double square brackets only, it will be subsetting. You have to give double square brackets. Check it.
Sir, single.
No, double square brackets, na?
Okay.
If you are subsetting, you have to use double square brackets.
Okay, sir.
Now do the summary of train num calls. Dot describe. So subject length, body length, mean paragraph, number of CTA, mean CTA, is image, is quote, is emoticons. All of them have values. There are no zeros. Okay, that is okay then. Yeah, good morning, Mujib. Yeah, we are working on the analytics with the competition thing. We have imported the data. I'll explain it. Yeah. Okay, all of you got the train num calls dot describe. Then obj list is equal to this. For call in obj list colon freq is equal to
Sir, it's not working.
object calls square bracket call dot value underscore counts. Print freq. Give me your Renidas number. Let me check.
So 441.
1 second. Huh? Four four one
908
908.
970.
Accept the connection request. There is a Jupyter notebook. Hey, you have given wrong quotes here. Double quotes and single quotes you have given both. You can either give single quotes
Yes.
or you can give double quotes. You have given both.
Yes, sir. Yes. Okay.
Correct it. So is underscore timer is all zeros. We have to drop is underscore timer. That's what we found out here. Do the same thing for test date also and find out whether the test date also is the same.
Done, sir. It is not working.
No. See, you have to re-import the data and run. First, remove the quotes. First, correct the quotes and run all the cells. Your data also might have got corrupted. You have problem in what? Object calls, right?
Yes, sir. Only object calls.
So I am pasting it in the chart window. Copy paste this list in the thing. Okay.
Okay, sir. Sir, we have to give single quotes or double quotes.
Anything, but you have given both now. Only one you have to give, either double quotes or either single quotes.
Sir, I
I have
use.
already given quotes here. Don't give more quotes. Only brackets you have to do. In the chat which I pasted,
Okay.
I have already given quotes. Okay. Paste it in double square brackets. Go to the top and run all cells. Okay, is under timer here
Sir,
also has all zeros. Yeah,
It's personalized.
is personalized.
All are zeros.
Is personalized also all are zeros.
Yes, sir.
Yeah, is personalized is also zeros. Yes, correct. Yeah. So is timer and is underscore personalized.
So each personal has two values, head 0 and 1.
No, but it shows zero only, right? See here.
So that's so each timer.
No,
right?
that is for
So-
each timer. Sorry. Not is personalized. Sorry. Each timer is zero. Is personalized, there are two values. Sorry. Only each timer has zeros. Only each timer has zeros. All right, guys. Participants, can you confirm you are done till this point? So train underscore object calls is equal to train underscore object calls dot drop is underscore timer comma axis is equal to 1. Test underscore object calls is equal to test underscore object calls dot drop is underscore timer comma axis is equal to 1. So Mujib, you are there?
Sir, yes, sir.
Did you import the data?
Yes, sir.
You have imported the data?
Yeah.
Yeah. So once you have imported the data, we have separated the numeric calls and object calls based on the data description. There's a text file which is sent to you, which has the data description. So based on the data description, we have separated the numeric calls and object calls. Similarly, we have also separated the numeric calls and object calls or categorical calls in test data also. All right. So once you have imported the data, going through the data description, we have separated the numeric calls and object calls, both in train and test. Same columns in train and same columns in test are numeric and object. So I'm pasting this in the chat window. If you want, you can take it from there. And same thing you have to take from the test data also. Test num calls and test object calls based on CTR test. Then we have done the describe of the numeric calls. We found out there are no 0 columns. All the columns have values. So we are okay there. Okay. So then we have separated the, we have taken the object list and then we have printed the frequency counts. And when we print the frequency counts of all the object columns, we found out that each timer is a column that has all zeros. Each timer is a column that has all zeros. Same thing happening in test data. Each timer has all zeros. So we have dropped each timer column from train and test data. So the object list which we copied from the top only, from the double square brackets, we copied the single square brackets and then do the frequency counts. And once you go through each of the frequency counts, you found out that each timer has all zeros. It's a single value column. So we are deleting it.
Okay, thank you, sir.
Yeah, got it? Yeah. Rest of the participants, you're done till this point?
Sir.
Sir, before we never separated the objects and numeric calls in test data. No, sir.
So what we are doing is we are doing a new process here. Earlier we used to combine and do it, right?
Yes, sir.
Now we are doing the second process where we are dealing train and test data separately. But whatever process you are doing on train data, same process must be done on test data also.
Can we go with the combined process also, no, sir?
You can go to combine process also, your choice.
Okay, thank you.
Now, tell me one thing, as Vikram has pointed out, if you look at the numeric data, is underscore images, is underscore code, is underscore emoticon. They're all having 6, 0 to 6, right?
Yes, sir.
So what should we do with it? Can we move them to object calls or should we keep them in numeric calls?
Two more object calls, sir.
What about others?
I
What do you
think we can keep it in numeric because that's
Which
what
one
the
says-
data description says.
It says
Number of
number
images.
thing, so we'll keep it in numeric calls. If at all the model does not fit, then we'll think about it, okay?
Sure, sir.
So what should be the next process?
Missing values.
Missing
We'll check for
values.
that.
Yes. CTR train dot is null dot sum dot sort underscore values ascending is equal to false. I think there are no missing values. Same thing, we will do it with CTR test. There are no missing values.
So we can check for any outliers. Like looks like there are.
We'll go step by step.
Okay.
We'll go step by step. See, the process is very important. Once you get the data, you have to follow the process. You remember EDA, we are doing still EDA only, right?
So can you scroll up?
Here or up?
Sir, yes. This.
We are still in EDA process, right?
Yes, sir.
So
Yes, sir.
what other exploratory data analysis we can do?
So we can check the distribution of the dependent variable.
Okay, that we can do. Now, let us say I want to check the distribution of all our numeric variables. I want a box plot of all the numeric variables in single. Or I think we have multiple numerical things, right? We have different numericals. Some are in very small, some are in very large. Body length is very large. Okay, no problem. Instead of plotting, we'll go with the other way. Num list is equal to this. For call in num list colon skew is equal to train underscore number underscore dot call dot skew print skew. So all the variables have skewness, right? Positive skewness. How do we add the name of variables to this?
So don't put it in double quotes. You can just put it as num list square bracket call.
Where? Here, huh?
Yes, sir.
Num list square bracket call comma skew, right?
Mm-hmm.
No,
No, it's not.
it will not take. So actually we have to access the list. Very highly skewed are these two. What are these two? mean paragraph length and CTA. They are very highly skewed. Even is underscore remote accounts is highly skewed. Print star A. Let's try this.
Type in call comma skew. Should work.
Call.
Call comma skew. Just call.
Yeah.
Yeah.
Call comma skew. Yes. So mean paragraph is 4.30, number of CTA 4.48, is underscore empty const 3.75. They will have big outliers. Even mean CTA length also has very high outliers. But looking at skewness, we can say, right? Only less outliers will be there is underscore image. Eight box plots can we print? Find out the code, participants. So I want to print 8 box plots. It's all coming in one place, but we want different box plots. Zoom we got. So for column in train numbers call plt dot figure train num calls dot box plot square bracket column comma what is equal to false. We get the horizontal box plots of all the numeric variables. You can easily see the outliers. Guys, all of you got this? So all this will help us. If the data is not fitting, then we can see these outliers are there. Then we can do some sort of standardized scalar or a normal scalar. Then we can try building a model and see how it affects. Okay. So this will help us for later if the model is not fitting. All right, guys, all of you got this? Okay, can we move forward? Object calls dummy is equal to p dot get underscore dummies train object calls. Object calls dummy dot shape. Oh, why it is not? Okay, we have to give columns list. Oh, what the hell? Oh, these time are not found. Oh, we have 102 columns, huh? But we have only 1880 rows. Is the data enough? And I think we have numeric columns also 8. So that means 110 columns of data is there. 110 into 20. I don't think we have enough data, right?
Yes, sir.
Okay, let us do one hot encoding. Shape and okay, we got encode also. One hot encode also, we are getting 1 or 2 columns.
So
we
why
have
is the number of columns increasing? Like,
one hot encoder and dummies are same. Get dummies and one hot encoder are same.
okay.
Only thing is get dummies will do 0 and 1 in the same column. The encoder does it in one row. So we have to do feature selection, okay? Okay, let's go with dummy. We'll go with dummy, right? So PLT dot figure fixed size is equal to 15 comma 10. Import Cbon as SNS dot heat map train numcalls dot corr comma not is equal to true. Now you can say, is there a multicollinearity issue? You can check. Check for multicollinearity. So we have to replace infinity with nan. And then we have to input the missing value. So we will go with normal y only. Okay. So post break, what we did was we concatenated the data frames, the object calls dummy and train num calls. And we also separated the y, which is the click rate. We found out there is a positive skewness. Logarithmic transformation is converting it, but see here, it has given a warning. Divide by 0 in quarter, divide by 0 means it will be infinity. So we will get infinity here. So some of the values are infinity, which are coming, minus infinity and infinity. So we need to replace those infinity values with the nan, and then we have to do the missing value imputation in the dependent variable. Okay. So what I did was I didn't take the log of y, I took actual y, but our model has failed. Model has completely failed because R square, what is the range? 0.60 to 0.95 is the preferred R square range, but we got 0.26. Got it, participants, all of you? So if you look at the leaderboard yesterday, some of them have talked about their approach. See, the target variable is highly skewed. There are many categorical and numeric for, they need to be converted. Log transform that reduces the skewness. I have added 1 before converting to the log to get rid of zeros present in the column. The skewness is reduced due to transformation. A separate column for Saturday is created and weekend column is transformed to Sunday. Only this effect of Saturday can be dealt separately. A new feature total is created by number of CTA into mean CTA length. A new feature par is created by body length by mean paragraph. Additional feature engineering for model 2. He has done that. He has built a model GBM. 5,400 seconds. That means almost 9 minutes. Not 9 minutes, 90 minutes. That's a very long more time. So let us see what this guy has done. So each price also we can drop because we have only zeros very high. So he is suggesting each price can be dropped. Then he scaled the data, cat calls, get dummies, so he has used PyCaret. So what we have done, we have to drop is underscore price also, right? So let us drop is underscore price. What do you say, participants?
Yes, sir.
Okay, drop is underscore price. And then try to fit the linear regression model like one more time again. So here, add a row, CTR train DF is equal to CTR train DF dot drop is underscore price, comma, axis is equal to 1. Is underscore price not found. What is the name?
So because you already put dummies, right? So it might have changed the
Oh.
column name.
Okay. So the deletion should not be here. The deletion should be before get dummies. So go to the command before get dummies. Add a column here and then paste it. No. Train object calls is equal to train object calls dot drop is underscore price, comma, axis is equal to 1. Okay, and here also remove is underscore price. Okay. And I will run all. So is under price should be removed before conversion the data into get dummies. Now, did the regression score improve? No, no improvement in regression score. But the number of variables came down to 94, right?
Sir, we have to remove it from test object also, sir.
We have to drop it from test date also. We'll drop it from test date also, okay? So there is no change here. Guys, build a decision tree model. Address Cindy. So decision tree model, or we'll do one thing. We have dropped is this thing price. Hey, we have not dropped the sender and all here. That's why we are getting such a bad score. CTR, we have dropped them, right? Yeah, we have dropped them. Okay, we have dropped them, no problem. It's correct only. Nizampet Rodega.
So we're getting 0.99
For what?
for tree, decision tree.
Okay, get the feature importance. ఇది వసంత్ నగర్ లో చాలా లేఅవుట్స్ ఉన్నాయి. ఏ లేఅవుట్ లోకి వెళ్ళాలి? బాలానగర్ కాదు, వసంత్ నగర్ లోనే చాలా లేఅవుట్స్ ఉన్నాయి.
వసంత నగర్ లో
చాలా లేఅవుట్స్ ఉన్నాయి.
ఏంటవి? పోకడపల్లి వసంత నగర్ 20 రోడ్ నెంబర్ 25.
చూడండి, రోడ్ నెంబర్ 25 వసంత్ నగర్ లో 9 ఉంది, 4 ఉంది, 15/5 ఉంది. చాలా ఉన్నాయి లేఅవుట్స్.
25.
వాళ్ళకి ఫోన్ చేయండి, మీకు చెప్తే అర్థం కాదు. All right, guys, decision tree I've run.
Sir, it is tree.fit.
Tree model dot score CTR train DF, comma Y. 99.98, right? But we are more interested into PD dot data frame CTR train DF dot columns, comma, tree model dot feature importances. Dot sort underscore index ascending is equal to false. So we have the variable indexes. So there are a lot of variables that have 0 importance. You can see here, right? So PD dot display options are there now. What are the display options?
PD.set option.
PD dot set options is there, right? Max rows is equal to, we want 105. Oh shit. So what is this? NP dot round. Comma 3. So you can see here, only those variables whose, I think we can eliminate all, a lot of them are zeros, we can eliminate them. Zero 0.12. Very few variables are important, right? హలో, ఇది కూకట్పల్లి వసంత్ నగర్ డ్రాప్ అమ్మ వస్తారా? అదే మీరు ట్రిప్ అయిన తర్వాత వస్తారు కదా, అయితే మీరు వెయిట్ చేస్తాం, అందుకని మీరు వస్తానంటే వెయిట్ చేస్తాం. ఓకే, డ్రాప్ లో ఉన్నాడు, డ్రాప్ అయ్యి వస్తాడు, పావు గంట పైన పడుతుంది. Okay, guys, all of you found it, right? There are a lot of variables which are found to be insignificant. Got it, all of you? So we will take all the variables which are found to be insignificant. I think many of them are insignificant. So we will take it from 0.01 to ease image. What do you say? Guys, you are there?
Yes, sir.
So we can select these variables and we can create an X variable and then we can build a model. That is called feature selection model. Feature
So-
selections can be done using decision tree or random forest or gradient boosting. Now we will rebuild our regression model with these own variables.
These are the weights only, na?
Yeah, these are the significance based on Gini.
So can we draw bar chart of these weights?
Yes, you
So
can.
we
So first we will what you call select the greater than based on index. So we need select by index value. Index greater than. Or we will do one thing, why to waste time? We will reset the index. Feature underscore aim is equal to dot reset underscore index. Each dot columns is equal to square bracket imp comma var. Feature imp is equal to feature imp square bracket feature imp dot imp greater than 0.12. 0.12 or 0.012? 01 or 01. So these are the important variables we have. Greater than equal to 0.12.
Sir, 0.012.
0.0. I gave greater than equal to 0.012 only, right? Why it is not taking greater than 0.012?
So we're showing only the first five.
Oh, sorry. Sometimes I also make mistakes. So all the variables are selected, right? These are the variables. Got it, all of you? Now you can plot it. Dot plot kind is equal to bar. Comma. How do we add labels?
Sir, Seaborn library is good for.
Yeah, Cbond library we can do. You try in Cbond.
Yes, sir.
Okay. I think we have to use PLT plot only. Okay. Dot legend. PLT dot X label. PLT dot X label. Where? No. It is saying dot plot kind is equal to bar. X label we got right. Here we got X label.
So I guess we need to put it as data frame and war. Like feature importance dot var or something, dot variable.
Okay, here, dot var. PLT dot show. All right. Somebody put a code. I think, okay. Excellent. Vishab has put the code. We will use SNS plot. Y is equal to in labels is equal to where. Whoa. No thing called where. No, this is not, we are getting the, we are not getting the name of the variables. This pandas data frame only. Y is equal to label or position. We are getting where, right? X is equal to X is equal to where, comma, Y is equal to imp. Yes. We got it. Yeah, variable names, we got it. Got it, all of you?
So could you scroll a bit up, like where you reset the index?
You want the reset index, right?
Mhm.
Here. Here I defined it p dot data frame dot columns np dot round comma 3 dot sort index sn is equal to 4 dot reset index.
Got it, sir.
Daddy? All right, guys, got it, all of you? So I have chosen variables with significance, chosen variables with feature importance. Greater than 0.12. Got it, all of you? So this is one method of selecting features. This is called variable selection of features because we have 102 variables, but the data is less. We have less data, right? We have less data. Data means rows. We have more variables, high dimensional data. Once you're done, please confirm.
Done, sir.
Okay, now we can take these variables as your independent variables, and then we can what to call let us say we'll build our read x is equal to CTR train df double square brackets feature underscore im dot var dot to underscore list. Oh, it is not taking to underscore list. Huh? Imp underscore list is equal to feature importance dot var dot to or dot as type list. Okay. Convert data frame column to string. Dot to list is also there. Huh? Okay, then we will do one thing. X is equal to CTR train df double square bracket fetch importance dot var dot string dot to list. As type string And how do we convert it? Yes. Dot apply. Dot apply. Str to list. We have to do individually. Imp underscore var is equal to feature underscore imp dot var dot import var dot as type string dot to underscore list. Imp underscore var. Okay. Sometimes the square brackets and all will cause problems, right? X is equal to CTR train DF double square brackets. Hey, what happened? Are in the columns. X is equal to take to train DF double square brackets columns. When you do it in 2 steps, I wanted to do it in 1 step. Oh, it's even less, 15. If you take important variables, it is even less, 15. R square is going to 15. So basically linear regression does not work for this model at all because of the skewness in the dependent variable. Because of the skewness in the dependent variable, linear regression is completely failing. You are understanding, right? Why linear regression is failing here completely? But in decision tree, you got 99 R square, right? I think the only way we can get good score is by doing logarithmic transformation of y. Got it, guys, all of you? So because of this skewness in the dependent variable, linear regression is failing. All right, can you move forward, participants?
Yes, sir.
Yes, sir.
Now, if you look at our this model, he has created something called bagging ensemble. Now, bagging ensemble means he has used multiple models. Okay, so we can use multiple models. See here, he has used cat boost, XGB regressor, extreme gradient boosting regressor, light phase boosting regressor, RF, gradient boosting, and extra trace regressor. He has used multiple models. Now you have to download this package called Carrot. If you remember the Carrot package in library in R, there we can do this multi-model things. We can build multiple models in one go, and we can compare those models. So same Carrot guys have created the same Carrot package which is there in R in Python also. So we have the different models. You can fix it, and then you can compare those model performances. And what he did is he took the average of each, weighted average of each model. Okay, so let us try this. We will try this one, participants.
सर
Yes, sir.
का मल्टीपल मॉडल जो है काम कैसे करते हैं समझ नहीं आ रहा.
It will build individually one model. It will build individually one model.
Okay.
Okay. Then what happens is, then there is a thing called stacked ensemble in Python. Now you can define how much, see, it has built each of those models individually, and you got the R squares. See here, you got the R squares. Now, based on these R
Okay.
squares, you can decide how much of each of the prediction you will take. So you'll assign different weights. You'll assign different weights, and then you will get the mean prediction.
Okay, sir.
Okay, combined prediction, you will get it. That's how he has done. So you can take each model, pip install PyCarrot. Let us see if we can install PyCarrot. Got an error. Okay, it has installed. I think I'll post this command. We have to use this one only. Because we're getting dependency errors. iCarrot is still incompatible. What is this? You guys say we have already done everything, but still incompatible. Yeah, got the error. iCarrot is not installing. Cannot import name, class name, features out, mixmin. So iCarrot is not working there. No. Or we have to do a Conda installation. Conda installation we have to do. Conda install -c conda -4 iCarrot. All of you do it in your Anaconda prompt. Anybody it's installing?